some of the, let's say, benefits of district heating are very much contributing towards a more national benefit, not just the local benefits of supplying the heat. And we see this as an essential part of the future. And I'll just give you two figures just to explain why this is so important. This thermal storage tank here is about 2% of the cost of electricity storage. So to build the same amount of thermal storage as electricity storage, you're talking fractions of the price. Then I'll give you one other statistic. There is twice as much thermal storage in Denmark as there is electricity storage in Britain. And what we found when we looked at the results was that when we looked at the business as usual scenario, if we included 50% district heating in Europe by 2050, so half of the heat demand in buildings was supplied by district heating instead of the business as usual fossil fuels, then we would have a lower fuel consumption, we would have a cheaper price for our heat, we would create more jobs because instead of importing fuels, we're developing local infrastructure in Europe, and we would use more renewable energy. So these are the numbers that we came to when we looked at this analysis of a business as usual versus a district heating world. If Europe meets its targets of a 80% reduction in CO2 emissions by 2050, how does it compare if we use district heating as part of that solution versus if we don't use district heating as part of that solution? A picture. And our key conclusion was that our mix of district heating, heat pumps and savings could achieve the targets that the EU has in 2050, but we would do it for about €100 billion a year less. So the price of the energy system in Europe would be cheaper if we did it with this combination than if we did it in the way that they had suggested. And hopefully now I've convinced a few of you that not only is it cold all around Europe, and not only is there a role to play for thermal storage and district heating in our future development of a sustainable energy system, but that the price is maybe not as expensive as people expect. I will just make one key point though. In order for district heating to have a role in this type of society, there is developments required in district heating as a technology. We don't simply say that it is good enough today and there we go. There is a lot of developments being undertaken in the district heating pipes and the different district heating systems themselves also.
I'm going to talk about the policies which are affecting district heating in Ireland, so just bring it down from the European level that David was speaking on. The residential sector in Ireland is the second largest energy consumption sector, and from a study that we carried out in Codima recently as part of our Sustainable Energy Action Plan, we found that 83% of the energy used in residential dwellings in Dublin City is used for space and water heating. So this means even if the electricity sector is to get to 100% renewable energy sources, it's only ever going to affect around 24% of the energy used in the residential sector in Dublin. There is a lot of focus on the development of combined heat and power in the national action plans due to the high efficiency of these production units and the fact that they can lower CO2 up to about 50%. But district heating then is an ideal way for us to not only reach the CHP targets, but also to contribute to the renewable energy targets of the heating sector, the energy efficiency targets, and also contribute to the renewable energy in the electricity sector as well. But there has been renewed focus on efficiency in the heating sector due to the new EU Energy Efficiency Directive. But there still is plenty of potential for district heating in Dublin. And we look at the heat density, as David mentioned, in Denmark anything over 150 terajoules per kilometre is considered high heat density, and there's plenty of areas in Dublin that have this kind of heat demand. We also know that there is positive interest in district heating from a market assessment that was carried out recently by Dublin City Council and Codima in this area here around the Docklands, where lots of small and medium enterprises were very interested in connecting to the system.
In 2008, the Mitchell's-Borrowee Community Regeneration Plan was approved in principle by the Department of Environment, Community and Local Government. Now to date, in our Sustainable Energy Zone, the 1 megawatt plant supplies heat to Tabernefa. This is a combination of new build and a retrofit former convent, which was the listed building. The plant at this stage is supplying heat and hot water to 100,000 units, 30 of which are private. The County Library, which is a 2,000 square metre building, The primary school, which is a 2,400 square metre building with 460 students, and the former convent, which is an 1,800 square metre building, which includes 8 apartments and the daycare centre. The cost of producing heat from the heat centre, as you can see, per month, it is on the far over side, but the average per year is 5.4 cents per kilowatt hour. This is the pay-as-you-save prepayment system. This is a smart metering network system that we're using in Tralee. Some annual data here in our next phase is to actually connect this 1 megawatt plant to the local Kerry General Hospital. All our energy is imported, so it is a huge bill that's actually leaving the county on an annual basis. Kerry has 55,000 hectares of forestry available. That's at the moment planted. The 60% of this forestry is privately owned by 1,500 farmers, so the local community is very much involved. There's an opportunity to create employment in the forestry and other direct and indirect industries attached to it. There's opportunity to reduce Kerry's carbon emissions. There's a reduction in fuel poverty and reduced burden.
My name is Paul Horn. I work at the Dublin Institute of Technology. Colleague James Rooney works with the Grange Gorman Development Agency. So I'm going to give a bit of the general background, and then James is going to say a bit more about some of the actual technical challenges facing us at the moment. Site is a mixed-use development with health, education, student residential, science park. So there's a whole series of uses to go in. DIT will be kind of, I suppose, the anchor tenant, about 60-70% of the space. Health, another about 25%, and then other uses. But focusing in on that, Elms, we are looking to, I suppose, mimic the Danish government in aiming towards being carbon neutral. And within that, buildings on a aim for natural light, natural ventilation. So the first thing is reduce the energy requirements. So orientations, it's looking at natural light, natural ventilation is kind of built into the master plan. In terms of rolling out a district heating network, on the first, and probably for us kind of a major issue is that on a site like this, it doesn't all happen overnight. It happens in a phased way. You have your first, for the whole thing to start, we needed a new hospital to sort of relocate all the activities that were on site. And this, without going into, I'll hit some of these, but there's a whole series of individual building projects that come along, each with their own finance to build their own, whatever it is, tranche of lands, and they're in various stages of development. And normally each building will come with the monies to build its own heat plant, but just its own little circle. And the real challenge, it's a big challenge in this is how do you front load the costs of a district heating network when some of this won't be delivered for 10, 15 years or so. In procuring that package, which was done over a year ago, really, that's the ideal time to put in the district heating network. And you're digging the whole place up, putting all the other pipes in. And we didn't really have any funding stream for that. But what we've done through the good agencies of the agency and our financial planners is that really, to be honest, what's done is the cost of a district heating network has literally been buried in the costs of the infrastructure.
So the first objective is always to prevent rather than cure. So we try to prevent, and then when we can't prevent anymore, we start to cure. We then had set the target of maximising the on-site energy production itself as part of the wider vision for the campus, which would bring in combined heat and power, an element of on-site power generation. We would drive that generation and the heat from it through a renewables resource, and we would look at the sustainability of the fuels and the supply chains that went with it.